Here I'd like to take a look at a proof of the equivalent and negation of the conditional statement and why these are correct. So if you look here at the equivalent statement, it says that if I want to convert this to and or is basically what is happening. This is the conditional statement. If P, then Q. If P implies Q, or if P then Q, is equivalent to the statement not P or Q. And how do I know that to be true? Well, if you forget the rule, just simply go through the truth table for it. Write P, true, true, false, false, possible, options, Q, pairing with it, true, false, true, false. Then P implies Q, which is this one here. True, and you go here, implies. The only one that is false is when true implies a false statement. So the first thing I do is I look, where does true imply a false statement? It's right here. So that I put the false in first, and then I fill the rest in with true. Now, I need also for this the not P. So therefore, I will take not P, the opposite of P, which is false, false, true, true. And then I will put them together as an or. So I am looking at not P. I'm looking at this one, and I'll make it nice and thick so that I can do this. So I'm looking at not P, okay, and or Q. And so I'm looking at this one, Q. And the only time the or, if you look over here, the only time it's false is when both of them are false. And so I look here, and when are they both false? This is where it's false. And so I fill in the rest. And so there is my statement. And you will see that I have basically the P implies Q. True statement is exactly the same. There's P implies Q, which is this side, and not P or Q is this one. And they are identical. Now, I'll go and I'll take a look at the next one, which is negation. So I'm starting out with the same concept. I'm going to start out with P, not Q. Okay. This is it. And I'm doing a negation of it. And so I need the negation of P implies Q. And so that is this one here. This is my left side, okay, that I want to compare. So now I look at what is the other choice? Well, it's supposed to equal the negation of. So this is, let me make this red. The negation of P and Q. And this is just a straightforward one. So this is negation of P implies Q. And I claim that P and not Q is the equivalent of that. And so I go through and I first do not Q, which is the opposite of everything here, not Q. And then I do P and not Q. So I am looking at, this time I am looking at P, this one here, and not Q. And I know that from my and statement, the only one that is going to be true is when they're both true. So I look here and I say, when are they both true? This is the only one where they're both true. So therefore, this is that. And I now have the equivalent, and I look at these two together, false, true, false, false. So I've just proven that these statements are correct. So if you're ever asked for the equivalent of PQ, if you go through this, you can find the equivalent of it by taking not P or Q. And here I could take P and not Q. And that's how, and you can prove that the two are this is the equivalent statement for it, and this is the negation of it. Thank you for your attention.